So this practical video is for scientific methods, experiment number 6, chemical experiment 6, the densities of liquids and solids. So there's 3 parts to this where you've got to use an analytical balance to just kind of be happy with your weighing the masses out of coins correctly, and then you've got to measure the mass of water to find the volume of a flask. So you use the density of water to find the volume of the flask. You're going to then to find the density of an unknown solution, and you've been left out as well a tray of pins, some brass pins, so you're going to find the density of this alloy, this metal alloy. So the first part asks you to look at the mass of coins. So when you're using an analytical balance such as this, the first thing to say is that if you open the door on the balance and you start to weigh, if someone was to be leaning on the bench while you're trying to measure, or talking around or stamping on the floor, you can affect the weight of the or the recording as will move over the balance top. So any recordings made should be with a closed door on the balance and with as much calm and order around the bench area. So it asks you to weigh out the mass of 2 coins first of all. So the balance here has a turn button. Make sure that this reads 0. If not, press the turn functionality. This is fine, and put the weight of a coin on, or coin disc, onto the balance and record it at 3.48.28. So enter that measurement into this part of the table, 3.4828. We've already done this before, we're just going to go back over what needs to be done. Take the coin off, place it there, allow this to balance to 0. If not, tear it again. Take the second coin, put onto the balance top, record the mass 3.55.78, enter this value as shown, and then take the coin off, turn the functionality again to 0, and then each coin can go back onto the balance area, and you'll weigh out then a final mass, and you look in here to determine the precision of the instrument. So can these 2 values add together to give this value as recorded together as 2 coin masses. The next part asks you to use the density of water to estimate the volume of the flask. So you'd be given some round bottom flasks. These are 50ml flasks. Some of the practicals could vary. You could have a 25ml flask, and you'll have a various neck capacity as well. So we're going to use these as accurate measuring vessels, these pincher meters. So we're going to use this as appropriate. You can't weigh a flask like this onto the balance, that will wobble. So what you should do on the balance is to place one of these rubber bungs. So this one's a bit wet to start with, so what we'll do, just grab some tissue paper and we'll make sure this is dry, there's no liquid or moisture onto this bung. You could be given a cork bung. Turn the apparatus, to 0. Eventually it will come up to 0. Weigh the mass of the flask and stopper. That's 57.8431. So we're going to record this as 57.8437 grams as it records to. And then you need the mass of the stoppered flask and water. So you take the weight of the flask. So you've been provided with water bottles, so you can either fill up at this point with the water bottle or just pop towards one of the sink base. So we'll just take the top off the water bottle, just drizzle our water in, we'll fill towards the top. Should you have an air bubble in the flask, sometimes it's better just to flick it out with your finger in case there's an air bubble. And you put then the stopper down, you secure it, and you'll then notice that the flask is wet. I've got my gloves on because you're going to see something in a moment about how to clean the flask afterwards. So again, get some more tissue paper, make sure that the outside of the flask is dry. Give it some wipe, remove any residual water from the outside of the flask. Back towards the balance area, place it on. So you've now got a mass of flask of 119 grams, 0.8215 grams. So then we now need to take the unknown liquid into here. So what do? This is just water. So this could be poured down the sink. This is just water. Now, if we changed the practical in time and this became an organic solvent, this would then go into the organic waste. You'll see this in a moment, but water can just go down the sink. And then you'll need to enter one of the fume covered areas in the lab. And you'll need to take acetone. This is why I've got my gloves on. And you're going to take some acetone and rinse round. So just take the stopper and rinse the top of the stopper. Rinse round the inside of the flask. Swirl out into the waste beaker. The flask. Swirl out. Swirl out. And then you're asked to blow compressed air through here. So you can just shake excess acetone off like that. In the fume cupboards, there are some taps, and this one is an argon tap, but I'm going to point this out on some of the benches as well. But I'd ask you to kind of stay near the fume cupboard area. We'll use argon for this instead of compressed air, but just make sure that you have a whistle of argon going through the tap, and just place the flask as appropriate, rotate around, empty, rotate around, empty, rotate around. This would only take about maybe a minute of time. It doesn't take too long. It's a bit like with nail varnish on. When you blow your nail varnish off, ladies, or you do gent. So you need about a minute's worth of time. By that time your stopper is dry. So we're quite happy. Once you've done, turn the tap off. I'll just point out in the lab facilities, there are benches, some of the benches around the areas of Mega Lab have either oxygen, the fume covers have argon, but some of the taps have CA, compressed air, which will also do the job too. So if you can go towards a bench with compressed air, do it that way. Compressed air is much cheaper to use than any oxygen and argon supplies that we have in the lab. So you've got your dried flask. You've to then take some of the liquid, unknown liquid, and then put it into the vessel. So drizzle in. Make this runs towards the top. Stopper goes down, and you'll notice now some of the solution comes out to the top of the flask. So again, grab yourself your tissue paper back, and with steady and firm hands give this a nice clean. You might need a second or third piece of tissue paper at this point. That's clean and dry. Place onto the balance. Now you record the mass of the flask with the unknown liquid, so we'll write that at 119.8648 grams. And this part you can calculate on your own. I'll give you further instructions on the day of the lab how to calculate this, so this is what you're going to do on your own. And now we've done with our liquid, we're going to place the unknown liquid inside a residual bottle, place it there, and now we're asked again to kind of clean this out with acetone. So what we are going to do, just say I know what the unknown liquid is for this practical. It could change year in, year out, so you might be looking at this in 20 years time and I'm an older man, but at the moment we're just going to use like a surfactant to detergents. So if we used an oil, we'd probably clean this out differently. But because this unknown liquid today is liquid based, we're just going to encourage you to take a touch of tap water, rinse, swirl, rinse, swirl, swirl and rinse again. Any waste tissue paper, this goes in your waste receptacles around the lab. Back we go again towards the fume covered areas. We look for some acetone. We've got to rinse and clean the outside of the flask. Good practice to clean the outside of the flask, the stopper, then the inside. Make sure all points of the flask internally are washed with acetone. We're doing this about 4, maybe 5 times. Notice each squirt I only had about 2-3 ml of acetone. Back towards the fume cupboard or towards an appropriate bench. Again, compressed air or argon or whatever it could be. Rinse around, empty. And again, this will take about a minute. So if you're doing 3-4 minutes of this, you should worry you're doing too much. So give it a rotate around, rotate around. Rotate around. A minute, that's done. Tap off, the stopper's dry. So then, go back towards the balance area. And the next part of the practical is asking you to find the density of an unknown solid. So what we are going to ask you to do is then, it says pour your sample from the liquid from the flask into its container, clean it, which we've done, and then add small chunks of the metal. Now this one we've got a metal as an alloy, a brass pin. So we've got a brass pin to the flask. So I'm going to ask you to take 5 brass pins and to weigh them out, okay? So it says here mass of the stoppered flask plus metal. We'll go back towards the balance area and make sure that's turned. We'll put the flask back on. We know the mass of the flask, it's what we previously recorded at the top line, 57.8437. So these are pins. Pins of course can be sharp on the edges. Be careful that some of the pins might still have some sharp edges towards them. Just take 5 pins, put them in there, weigh them. So this gives us mass of stoppered flask plus metal, so 59.3620 grams. And then we've got now the mass of stoppered flask plus water. So as it says here, we need to now put water into the flask and do what we've previously done. So we'll take our water bottle and we'll put some water in. So again, I'll take a bit more water, pour in, put the water towards the top part of the flask, on the neck, so for filling, take the stopper, And then I'm going to go towards the sink area to do this. I'm going to grab some tissue paper. We go to the sinks on the benches. Can I just say we never use these sinks in this lab to put any solutions down. This is only for hand wash and face wash in case of emergency. So we can either go to these drip cup taps, or we'll go towards one of the edge benches. Stopper in place, overfill, and again clean excess or remove excess water at the base of the flask. Clean the neck, dry. You might need 2 or 3 bits of tissue paper to do this. Make sure as well that your gloves are dry so you're not transferring water droplets back onto the flask. We come back towards the balance area. I'm going to place back onto that. So we've now got a mass of 121.1141 grams. So this part you can fill in on your own. Again, further advice might be available later on about how to do this. So what do we now need to do? What you've done with the water, this is just water. So again, carefully make a choice to decant down to there, and then pour out and tap out into the weighing boat. You've now done your practical. You've now to take your appropriate values and work through your sheet. So this is a practical which gets you to know even more about the uses of 4 decimal place balance. It introduces the concept of chemistry, having physical entities such as densities. So we're looking to find out the density of an unknown liquid. We're looking to find the density out of a metal sample. This metal sample is an alloy, brass pin. And again, we refer back to the use of the balance top. So we just say to you here, if you're using a balance top and you were to lean on it while taking measurements, this would affect the measurement value. So please don't do that. And as well, make sure you are recording the mass of the flask of the apparatus. The reason behind this practical is to get you to be aware of what the mass of flasks are and to record the mass of flasks before putting anything into it. And this is a very important principle when you do chemistry, either this is a foundation year or towards a first, second, third year, or an undergraduate degree, honours degree, or an MSc and PhD. Get to fill in data tables, record masses of flasks, record and scribble them down somewhere. You've got a data sheet for this today. So this is chemical experiment 3, and I thank you for your attention to this video, and we stop.